This is a brief overview of my project, getting started with embedded systems. I was tasked with creating a basic digital signal processor. So I started with using MATLAB to create a basic filter and signal so that I could extract the values I needed from it. So as you can see, I made a break frequency, I made a sample rate, I put it into the Butterworth filter, and I was able to get back the values that I needed for my B&A coefficients. I was able to get a test and model result for my input and filter to output, as well as get the bode plot and the frequency out. This is the C code that I've been using for my project. I started by putting the B&A coefficients uh, in. I used Frank's code for the systolic pass-through as a basis, as I had a lot of the functions that I would have had to recreate, and by sampling this I was able to save myself a lot of time. I made the filter using difference equations, and the old numbers are shifted down as seen here. I included a systolic function, as this would allow more accurate sampling. So using our sample rate required, I was able to get that every 400 ticks a sample would be taken from the signal being input. This calls the systolic handler, which then reads the value and puts that value into a buffer. And while the code is running and not being asked to do the systolic handler, it is trying to process what is in the buffer here and then outputs that as part of the filter. Over the course of doing this project, we were required to use GitHub and the README files to document our progress. So here's a quick overview of what I have documented. So we have an introduction to the problem, all the stuff that I've been using, so the microprocessor and the different parts, the interrupt, the buffers that I used while creating my low pass filter. A bit discussion on MATLAB and the filter itself. Here's the circuit diagram and discusses why I used the ports that I did. I go over some of the issues I had while going through this, as one of the ports broke and I had to try and then find out what wasn't working and why there was no output. I go over the systolic interrupt and how it's used, the buffer and how it's used, and then the results. So as you can see from the results, when I input a sine wave, I do get quite similar, although not exactly the same results back out. And this is the same for square wave inputs, how I get the expected result. Unfortunately, due to not having a function generator at home, I'm not able to demonstrate the code, but I do have these screenshots taken from the lab when I was there.